Hi guys, today we're going to do applications of exponential functions. So first, both growth and decay can be modeled by the following formula. A function of t is equal to the initial amount times 1 plus r, which is rate, raised to the power t, which is time. So where a sub 0 is the initial amount, which is the amount at the time t equals 0, and r is the rate. If r is greater than 0, then the initial amount will be growing exponentially. And if r is in between -1 and 0, then the initial amount decays exponentially. So let's try an example. Suppose a radioactive isotope decays so that the radioactivity present decreases by 15% per day. If 40 kilograms are present now, find the amount present 6 days from now and 6 days ago. So we're going to use the formula that we were just introduced to. We have decreasing by 15%. Our initial amount is 40 kilograms, and 6 days from now, which means t is equal to 6. We're going to plug it into our formula so that we get a of 6 is equal to the initial amount is 40 times 1. My rate is decreasing by 15%. So I'm going to rewrite that percentage in a decimal form. But since I'm decreasing, I need to be subtracting. So 1 minus 0.15 raised to the 6th power. So we have 1 minus 0.15, which is 85 hundredths, raised to the 6th power, times by 40, and we get 15.09 kilograms. So that's how much is left from 6 days from now. Now we want to look backwards and think about 6 days ago, what was our amount? So now that's like saying we're at day 6, but we don't know our initial amount. So that's what we were going to solve for. So our AT, or A of t, would be equal to 40 kilograms. We're solving for our initial amount times 1 minus 0.15 to the 6th power. So I once again get 85 hundredths raised to the 6th power, and I'm going to then divide by that on both sides. And I get a sub 0 is equal to 106 of a kilogram. When we are working with compound interest, we have two different formulas. So if we have a principal P is invested at an interest rate R for a period of T years, then the amount A of the investment is given by. So the amount of our investment is equal to P times 1 plus R divided by N, all raised to the N times T, if we are compounded N times per year after T years. And we have our amount of our investment is equal to our principal times e to the power of RT. And this is if our interest is compounded continuously after T years. So let's look at an example of compound interest. Suppose you invest $100 at 8% annual interest. Calculate the amount that you would have after 1 year if the interest is compounded, A, quarterly, B, monthly, and C, continuously. So, depending on how often the interest is compounded, then depends what formula we're going to be using. So since it's quarterly, we have to use our first formula, which means if quarterly throughout the year, that means we would compound our interest 4 times. So N would be equal to 4. Monthly, N would be equal to 12. And continuously, we use our second formula. So let's plug in to find the amount that we would have. So A for quarterly, our principal interest was $100, so 100 times 1 plus R is 8%, which means I'm going to put 0.08 divided by N, which is 4, raised to the power of N times T. So after 1 year times 4 times we are compounding, so we're raising it to the 4th power. If you put that in your calculator, you then get $108.24. Now we're going to, for monthly, do something very similar, but instead of N equaling 4, we're going to have N equal 12. And 100 times 1 plus 0.08. And we get $108.30. Then the last part of the problem is we are compounded continuously, so we're using A is equal to PE to the power of RT. So AT is equal to, our principal amount is still 100. E is a button on our calculator, kind of like pi. It is a symbol that represents an irrational number, and R is 0.08 times 1. So I put this in my calculator and I get $108.33. That's it for tonight.